Hi, everyone. Can you hear me? Well, enough, maybe. Hi. I actually retitled my presentation to Digital Curation of Human Anatomy because, kind of going back a bit, I'm a second-year student at BMC currently, and I'd like to tell a story about my experiences this past summer working for a project dealing with digital curation of human anatomy. It's for the project itself is called NLM 3D, stands for National Library of Medicine 3D project, and it's part of the institutes at the National Institute of Health in Bethesda, Maryland. My original plan for this talk was to kind of focus on the methodology of how I went about kind of contributing to this project, but I decided to shift focus a little bit and share more about the motivations and the potentials of the project to maybe kind of hit a few more notes for people who kind of care more about the different parts of the story. So for this talk, I'd like to first go through my motivations as I went to help with the project. I'd like to next go on to the project background. And then after that, my goals and my execution of those goals in this project. And after that, the kind of project prospects as it's nearing launch next year. And lastly, my takeaways. So why did I want to get involved in this project? The reasons were threefold. The first was the opportunity to apply many of the learned skills in my first year at BMC to kind of distill these skills into a meaningful project. Those skills being anatomy extraction from medical imaging data, of organic 3D sculpting, and of rendering. And the second reason was, I wanted to have the experience of working for a different work environment, of kind of working for a government institution and seeing the bureaucracies and kind of the freedoms and the flexibilities involved in that, and just kind of open myself up to a different experience in the summer. And the third was, I thought it was a good time to work in the USA this summer because of the very good American dollar, But then it really went down basically throughout the months that I worked there, so not so much anymore. Okay. So first, I'd like to briefly talk about what this project is and what's been done so far in this project. But before I go on that, I have to go back over 20 years. Over 2 decades ago, the NIH actually took on a different project called the Visible Human Project to generate high-resolution volumetric cryosection images of a man and a woman. And crucially, these were high-contrast, soft tissue data. And because of that, there's a lot of anatomical information that can be kind of preserved and worked with that aren't really possible with kind of the more typical volumetric imaging data, such as through MRI and CT. And it was well ahead of its time, so ahead of its time that it was dozens of gigabytes of information in the 90s, and there wasn't even really like any tangible media to store them back then. And really, it was only with a lot of catching up of typical technology in terms of graphical computing, advancements in imaging processing and software development, that now these are usable and they're processable. And now that there is a lot of broader user access through the web, and also a lot more usage cases as the general audience kind of have the digital tools to interact with kind of 3D anatomy, that this project can actually be used. And because of that, the NLM 3D project kind of was synthesized. And really all it comes down now is we need qualified curators to process the raw data. So NLM 3D, it's spearheaded by Kristen Brown. She is a 1T5 BMC graduate who is a classmate of Derek Ng's. And her main goal of this project was an open access, easy to use 3D anatomical library with assets that are professionally curated from imaging data. And she's starting with the visible human data. So one big question to ask is, why imaging-based? You know, there's a lot of good, solid resources of human anatomy online and also commercially. So why imaging-based? Because it is really the kind of only tangible way of permitting structurally and spatially accurate anatomy in a 3D environment. Spatially, as in the kind of interrelationship between different organs, and structurally because imaging data really, good imaging data captures a lot of the complexities of soft tissue. And the project was approached on two fronts, one of 3D model development, of data acquisition, optimization, of segmentation of the imaging data, of remodeling of the models, export, testing, and packaging. And on that front, the NLM 3D project currently is really encompassing quite a bit already of the visible human male data set. And for the female, it's only scratching the surface. And the second front of the project is the website and content management, which Kristen is really triumphantly tackling on her own currently. And she needs help. But no, she's very competent though. She's a very good learner, and she's able to really champion it. So knowing a bit more about the project now, I'd like to run briefly through how I envisioned my participation this past summer in the project was and how I went about executing them. So I had two aims. Why are the dogs so, okay, I'm sorry for the formatting, PowerPoint always. I had two main aims for this project. One was to further help contribute to generating 3D anatomical assets. As we know, if we consider all the different soft tissues involved in each and every organ in our body, there's just endless amounts of potential models we can extract to be part of the finished product of an assembly of human anatomy. So I wanted to really get in this summer and really just kind of give it my all in terms of contributing to curate the models. But secondly, one of my aims is to expand the project workflow. Before I came to this project this summer, the project was going to offer basically high-quality 3D meshes of different organs and tissue types in good spatial relationship to each other. But that was it. So I wanted to see if I can provide ideas about what more we can provide to the end user. So how I'm executing that this summer. I extract and restore data set structures into 3D anatomical models. I aim to establish resources for organ colors and organ material characteristics for starting points of the assets as they're provided. And I performed texturing and rendering tests to kind of consolidate all of that. So in terms of generating 3D anatomical assets, this is the kind of just a schematic of the visible human female. And I'm highlighting some of the structures I curated this summer. I wanted to balance between high output of anatomical curation and also engaging my own interests, because it is extremely tedious work to manually extract anatomy and also do a lot of procedural modeling, remodeling, and reconstruction. So I decided to curate a broad range of tissue types, bone, musculature, major organs, and some vasculature. I'll kind of run through my methodology briefly, and it's really taught very exquisitely by Kristen, who basically was my mentor this summer. Start off with the soft tissue imaging data, which is converted from 24-bit color to black grayscale, and then so that just to preserve the dynamic contrast and use that as a basis for segmentation. And the software we used is 3D Slicer. because it offers kind of a lot more robust technicality, more robust capabilities than some of the other kind of competitors, such as Osirix and Horus. Tissue types are thresholded and segmented, labeled, and then crude 3D meshes are exported. And then they are cleaned up and scouring most of the artifacts from the segmentation process, but also scouring pretty much all the details. And then lastly, the details are restored manually and I guess artistically to sculpt back the details without adding anything. So that the trick was to not change the forms of the anatomy, but at the same time referencing both to anatomical literature, but also to the original high artifact models for details. And usually this is where the curated 3D assets are left as is for database deposition, but I wanted to kind of see if it can be pushed a bit more, so I'm going to how I wanted to expand the project workflow. I wanted to provide more usable assets to the end users, with things with tissue coloring and surface characteristics, so that there's more flexibility if the end user wanted that. So I decided to iterate and compile a number of style guides for those and do rendering tests. So I wanted to establish tissue colors. I indexed a number of colors using some criteria in terms of the reference needs to be from surgical or autopsy photos of various organ and tissue types. 4 colors were indexed for each tissue type, and everything is compiled into a style guide format. And from that point on, the assets can be manually texture painted in 3D software. I also wanted to establish tissue surface characteristics. It was kind of a proof of concept. It was a cyclical process where I set preliminary surface characteristics onto, let's say, a knee joint with cartilage. And I compared that against references. And I tweaked the surface characteristics in the 3D environment, rinse and repeat until I found it to be satisfactory. And that was compiled into its own style guide. So I ended up with this expanded workflow where the 2 supporting workflow introductions of tissue color and tissue kind of material characteristics are fed into the primary workflow to kind of provide, I guess, some structure for future as the project keeps going. And here are some rough rendering tests to see how the tissue color and tissue surface characteristics can be relayed in application as different organs were curated. And I'm excited to see how these style standards can be expanded into the entirety of the project. So that's kind of the part I played in the project. But the project goes on, and next year is kind of a big year for NLM 3D because Kristen is very tentatively, predicting that next year, 2018, will be the launch year for the project. So because of that, I'd like to kind of talk about the potential uses and also future prospects past the initial launch next year. So in terms of almost current utility of the project as it launches, one big aspect is general education in the domain of anatomy. To have an open access, easy to use kind of library for different educational resources to kind of siphon from is going to be big. But also, in addition to that, another utility would be in terms of medical training content. Physically, through a lot of 3D printing technologies, can be kind of funneled into surgical training, but also in terms of having an asset basis for generating training content in VR or AR-based environments. And lastly, it will be a very useful kind of source of content for our practice as biomedical communicators in terms of any anatomical, medical, legal, or surgical domains of work. NLM 3D assets can be used as either indirect reference or as direct sources of derivative 3D work. And in terms of future potential, there are some things which I'm really quite excited about for the project. One is of high-resolution organ curation. So, for instance, brain archival. There is a lot of high-resolution volumetric brain imaging data available already. And if the project gets its hands on that, then we can kind of curate and have a basis for, I guess, both medical research purposes as well as for, goes back to us, about medical communications purposes. And lastly, kind of expanding into different scales of magnification of tissue and cell scale curation. There is a lot of imaging data for those already, and it would be good to consolidate and curate, let's say, different cell types, cell organelles, et cetera, and offer that as a source to education and beyond. So wrapping up my talk, I'd like to touch on things I learned, partly because they really helped me grow this summer, and I want to kind of remind myself of that, and also partly because it may resonate or inspire some of the younger classmates in the room to get the most out of interesting opportunities like this. Of course, you know, kind of going out of the comfort zone this summer, kind of involving in a project like this, I learned a lot of technical skills, not just learning, but also becoming more proficient in these technical skills. But I think more importantly than that, I gained a lot of working skills, you know, or kind of developing overarching strategies, but at the same time, segmenting them into bite-sized chunks. It was really valuable because, you know, a lot of, a 2-month project puts a lot of time pressure, and this ensured the highest goal-oriented productivity every single day. And things like balance between work and leisure, we in BMC right now are very myopic about balancing that, you know, for very good reason. But opportunities like this force us to, you know, find that leisure time and also through that get a lot more productivity. And lastly, willingness to be humble and learn. As biomedical communicators, we will always be students. And if we stop being students ever in our lives, we will fail. And the world is full of teachers, them being experts. So with that, I'd like to thank you all for listening. Thank BMCAA for kind of allowing me to talk. And thank the people this summer, the great people at NLM for you know, help fostering me throughout the process. Thank you.